G'day guys, how's it going? So I have some cell frames here that just got here from China, wherever they come from, Hong Kong, China, whatever it is. Grabbed off eBay, and we're going to remake my e-bike battery. Now my previous e-bike battery was in bundles of 10 cells just stuck together. I had little cell separators just like these out of the old Makita lithium 18 volt drill batteries, and then just duct tape and solder up the ends. I had 13 of them in series. What I'm going to do this time is have a 200 cell brick. Should be nice and solid and all one big piece. I'm going to mount this down one side of the bike, then mount the motor speed controller and the circuitry, and maybe even an onboard charger on the other side of the bike for equal weight distribution. But at 50 grams per cell, this will be about 10 kilos. Now, the cells I'm going to use for this are INR 18650 20Rs Samsung cells, and I've got a massive great big tub of them beside me. I'm just going to go ahead and place them all in this until it's full. Last three. Alright, that's 200. That is 200 INR 18650 20R Samsungs. Yeah, you might have seen me pick a few out of the bunch in the time lapse. Where are they? There's a reason I picked a few out. I'm normally pretty good when I'm processing these, but I processed a bunch of them, which were 13Qs, sorry. High drain, 1500 milliamp, 1300 milliamp, something like that. Lithium cells. They're in a lot of earlier Milwaukee 3 amp hour drill packs. A few other brands, Ryobi I think too. So there's a few of them in the mix. The other thing I found was a few rusty ones. They just need cleaning up with a little wire wheel or whatever. And a few other lower capacity ones like in the 1700s. They're a bit of a weaker cell. Still going to be fine for other things, but for this project we want the good ones. So everything in here is between 1890 and 2300. So I'm going to set that as an assumed capacity of let's say 2100. So if we go 2.1 times 200, 420 amp hour. These cells themselves have a 20C rating, so times that by 20 again. 8,000 amps, 8,400. You times that by 3.7. It's a 31 kilowatt jolt. So it's a ridiculous kick. If we go 420 amp hours, we times that by 3.7, which is our nominal voltage, and have a 1554 watt hour pack, or 1.5 kilowatts, which is quite substantial. My previous pack was I have to go back and watch the videos. I think it was 1.1. They were 21 amps per pack of 10. That's 13 in series. So we've got 200 cells. We divide that by 13. We'll have 15. 15.38. That's not going to work out ideal. Anyway, we'll have about 15 cells per 13S pack. So be 30 amps times 55 volts fully charged. It could end up being 1600 watts, which is cool. I'll probably only charge it to 52. That'll get us back down at our 1500 watt mark. So that's the plan. Next step, let's get these cell frame tops on and top them all off. Put some frames together. I'm going to go with one of these frame setups again for this e-bike. Well, now for this e-bike. Like this one over here. It's only just in frame, sorry. The micro DIY Powerball test subject. We are actually going to self-fuse this. We'll get to that another day, another episode. The main reason we are going to self-use it is just safety when you ride. My original e-bike battery caught fire while I was riding, through to my own stupid fault. Poor connections, poor terminals, lots and lots of current, and I was holding it flat out, working it really hard. So 100% my own fault. Can't blame anyone else for it when I built it myself. So this time we're going to build it better. First things first, having a big pack that doesn't move and they're all stuck together. Even if there is a bit of movement, I can always run all the way around the outside with a hot glue gun and stick them all together. So cross the bridge when we get to it. The always got to concentrate a little bit when you're doing these, otherwise you'll end up stacking them together wrong. Have to pull a bunch of them apart. Once you've done a few of them you get a bit better at it, but it's been a while since I've got to play with any. Kind of only playing with spare money at the moment on this project. I might switch that one around. That internal, just got a broken one. Must have just been from shipping. I do wrap them up pretty good normally. I got a like an airbag kind of thing, all pretty safe. Reasonably fragile by then they're on their own. I tend to find you're better off making strips and then clicking all the strips together. Just like I haven't done this time. I did it with the bottom ones. That's better. You know what, you just want to make sure they're all clicked together firm before you start trying to get them on your pack. But everybody does everything differently. What works for me might not work for the next guy in the line. Okay, so work your way around, just wiggling yourselves. It's nice to have a screwdriver or something to poke them with. You will get the odd unruly one that wants to sit funny. As you square them up, you will start pushing them in nicely. Literally only takes one sitting a few millimetres out to make it hard. Don't push too hard, you don't want to break your cell frames. You've got to push reasonably hard. It's not the simplest thing to get them in there, but what I'm saying is don't go crazy. So it's just that one there. There's our broken one. Trying to hang us up to dry. We'll fix him. One other thing we're going to try with this big lithium bank, it will be for the e-bike, and will quite possibly be mounted fairly securely to the e-bike, but my mate also has a 48 volt power inverter. Well, it's actually quite a flexible voltage, made for kind of more modern works that we're playing with. So, as we know, lithium batteries come in different shapes and sizes to your traditionals, and I was talking to him about building another e-bike battery, so we might see if we can't borrow his inverter or at least have a play with it and this battery, see how it goes for compatibility. The other thing I plan to do, using a better version of this boost converter, is making a charger that charges this big bank with one of these off my solar power setup, so the e-bike will be carbon neutral. Maybe, if we get to it. It's not the biggest deal. You still can't compare the cost of a little bit of electricity to ride an e-bike to running costs of for a motor vehicle, for instance. Every time you start a motor vehicle, you're wearing it out, and a brushless hub motor is certainly a whole bunch more reliable than a internal combustion engine. Some people have the geared hub motors in their bikes, but mine's actually a ungeared one. The geared ones, some of them can actually go faster. One of the things that holds mine back speed-wise a bit is the fact that it's a direct drive hub motor. Some of the geared ones just have a bit of a gear ratio to help them pick up more speed. And like that, there is a 1.5 kilowatt 18650 brick. Isn't that beautiful? Just beautiful. Now, if I was really smart, I'd stack a certain amount of cells, the 15 cells, and then flip and then stack 15 cells, and then flip and then stack 15 cells. By doing it this way, it means that there's going to be 15 cells and then a jumper wire, and then 15 cells and then a jumper wire, back and forth. I think I can still make it look neat enough. If my idea was that if I run my jumper wires through these spaces, so there's a nice gap between each four, the centre of a four lot of 18650s, so we can run cable through there and up to our termination, because there's not going to be a solid bus bar. I really wish I've got enough cells. I could probably make 3 of these like this. I really wish I could make a bunch more, but yeah, I've probably got another realistically 300 odd cells actually, so I could make another one of these, or I could make 3 100 or 4 100 watt ones, but anyway, 400 cell ones. So that's that part made. They are all 20Rs except for some 22Es, which have a less of a C rating but a higher capacity, so it evens itself out. My motor at maximum discharge at 48 volts is pulling 30 to 32 amps, and these are going to be 30 amp cells, so it's only 1C, 30 amp per series block, so it's only really going to be pulling 1C, which is actually pretty sweet. My original one was 20 amps per block, so it was going to be pulling, they were around 20 amps, so it's pretty rough, so it would have been pulling over 1C, 1.5, closer to 2 when you really stored it out. Now I'm actually going to have more current available to the motor this time as well, because these won't sag, so the kilowatts it's going to use are higher. 1, these won't sag as much as the other pack did. 2, it's going to have better terminals, and 3, I'm going to run decent sized wire and a 50 amp Anderson plug right to the motor speed controller. I'm going to trim as much of the wiring up as I can to the motor speed controller and make it shorter and better. Another thing I'm going to do is the wires that go down to the hub motor itself are quite small, so I'm going to cut them right at the motor speed control, right at the hub, sorry, as short as I can, like real short, close to the hub, and go to a much bigger wire gauge right from there, just to get rid of the voltage drop up to the motor speed controller, because it was a weak spot. They did get warm. That means we'll get the most power to our wheel rather than wasting any, which means 1.5 kilowatt at a constant hill climb. It pulls about 1,000 to 1,200 watts, so it means you can do that for a whole hour, and like I could do 30k an hour uphill with 1,000 plus watts, so that's going to go a long way. You're never going to go uphill for an entire hour anywhere here locally, so it should be perfect. I know it looks massive. It is reasonably heavy. Like I said, I reckon about 10 kilos. We will stick it on the scales, but the bike frame that I've got, you may remember, the blue e-bike, is actually a lady's bike, and I reckon this will fit under the nose of the seat down this end and still not be too high on the headstock of the bike coming up on an angle like that. And if it is, we'll cut the bar out and make it a different height so we can keep it centre. That's all we're doing tonight. I'll get hold of some decent copper cabling. We'll make up some individual pack bus bars in the next couple of days, and once we've done that, we will work our way through connecting them all up, give it all a charge. I'm going to have to get hold of a IMAX or a iCharger or whatever. I'm going to give all these a bit of a tap. What you do is you use a soft face hammer, like a nylon faced hammer, or like a dead blow hammer, the big orange ones that have got the lead in them that are really soft. Give this whole thing a hit and just get them all packed down as tight as they go, and then we can do some soldering. A lot of these are already pre-soldered. For some reason I got excited one day and started soldering them up just to tin them after I processed a big white bucket full of them. The end game was always they're going to be soldered into something, so it's not a big loss. Yeah, I've still got that many left, and that was our first real power wall kind of. That's a 3S 40p block. That was the first one we did, and terminal wise it's good. There's about half a kilowatt hour there. They're only 1.5 amp batteries, 1500 milliamp hours. These are 2, so and there's instead of 120 there's 200. Thanks heaps for watching, guys. Hopefully you're interested in this e-bike build, and we'll get it all done. Then we'll do some runtime testing on it. It does about 40 to 45 kilometers an hour depending on wind and the road you're on. And that was with shitty terminals, small wire size, and a pack that sagged really hard. So we should get a lot better than that. We're going to actually have a nice bright blue little voltmeter up on the head stem of the bike, so we can see the battery voltage and sag when we pull the throttle on. We'll probably end up with a watt-hour meter like that somewhere too. Probably right before the motor speed controller this time, and get rid of all the shitty connections that I had last time. Last time they all had like bullet connectors, ones like the banana plug ones, but the automotive ones. And they used to get warm because you're pulling 30 amps through them, cable too small, all that. So the cable's not going to actually, because they were daisy chained in like little bricks. So basically they were like a brick like this that I made, and then there was just a wire, let's say that long, 150mm long, off that one to the next one with bullet connectors between them all. Heaps of voltage drop. Stupid, but I just wanted to get it going because my hub motor, I thought I bought it from Hong Kong, but I bought it from Australia, and it turned up real fast. But yeah, I can't wait to get this done. Hope you enjoyed. Thanks for watching, guys. This is going to be a 200 cell 1.5 kilowatt e-bike battery. Catch you on the next vid.